Good morning, everybody, and welcome to our webinar with Knowi, Quanta, and Cloudera. My name is Kim Lockett. I'm VP of Marketing here at Knowi, and we will be discussing today how to solve the data challenge in connected transport. So a couple of quick housekeeping items before we get started. First, you guys are all on mute. So if there's a Q&A box in your Zoom panel, if you hit that, you'll be able to type in a question. We'll have plenty of time at the end to get to questions, so we want it to be as an interactive a session as possible, so please take advantage of the Q&A box. Next is that we're going to record the session, and you're going to get the slides as well as a recording of the session in your email box after we're done. With that, let me introduce our speakers for today. So I have with me Manny and Ash. So Manny is one of our expert Knowi solution engineers. Those of you who are already Knowi customers probably know Manny quite well. And Ash is a really smart guy that we know. He's an expert in IoT and currently is a big data IoT evangelist at Cloudera. So I welcome both of you to the session. And then lastly, just a little bit about Knowi and Quanta, in case you don't know us. So Knowi, we're an augmented analytics platform. Our big claim to fame is that we can connect to any data anywhere. So we don't care if that is relational data, unstructured data in a NoSQL database, or APIs. So we can connect to any data source. We don't move any data. We don't transform any data. We just work with the data where it is, and then allow you to join across different data sets and then bring that data into visualizations. We also combine AI and NLP. So we allow you to get analytics out to all of the people in your organization that need them, either through traditional dashboarding, through alerting, or through natural language queries. So in the IoT space, we have a number of clients. I think our largest one at the moment is our partnership with Verizon ThingSpace. So it's we have a pretty good fit with our IoT because the nature of the data. And we'll be showing you a live demo a little bit later in the presentation. But I'm going to hand it off to Ash to talk a little bit about Quanta.
Hi. Yeah. Hi, everybody. Thanks for having me. I'm really excited to have a chance to talk to you all. I'm Ashley Tarver with Cloudera. And at Cloudera, if you're not familiar with what we do, we are actually one of the platforms or the data sources that Knowi would touch. So as part of the big data platform based on a lot of the open source Apache Hadoop technologies, we built an enterprise data cloud that allows companies to aggregate and consolidate their data into a large platform, either on-premise, in the cloud, hybrid cloud, or any combination thereof, and it becomes one of the premier data sources that Knowi would attach to when they're doing their analytics. And Quanta is one of our partners at Cloudera, who helps us in the systems integration side of the business. They have predictive analytics solutions that are uniquely tied to specific use cases and specific industries. They can customize machine learning algorithms for unique IoT use cases related to predictive maintenance, manufacturing. In this case, we're talking about autonomous driving. They provide consulting services and kind of a smart city, smart utility, smart car expertise across multiple domains. So together, the three of us provide kind of an end-to-end method for analyzing, controlling, managing, and predicting the data that you might collect. So what I'll do is I'll jump into our discussion. Today, we're focused on a really interesting topic that I'm especially passionate about, and that's self-driving vehicles, because Without telling my age, I grew up in the time where we were watching the Jetson cartoons, and I was just fascinated with having your own robot at home and having the ability to have flying cars take you to school and back. And I was just dying for the opportunity as a kid to see that come to reality. Now, as I get older, I have conversations at the cocktail receptions with my friends when we're hanging out together about whether or not self-driving cars is it going to make our lives better, or is it truly the beginning of the robot apocalypse? Because as we start to get into the slide deck, I'm hoping that we'll be able to show you examples of how significant a transition this is going to be, not only for us in the automobile industry, but society overall. So let me push forward here. The presentation I like to give, and I've done this a few times, is kind of broken up in 3 areas. What's the implication of moving to to an autonomous society? How is that going to look? What's the rationale behind that? Number 2, how does the self-driving car currently operate? How are we collecting data? What does that look like? How do the cars manage to do that? And then finally, what's the impact in the data management space? How do you organize, control, and analyze this data to make it useful? And we'll have plenty of time for questions at the end. So as I'm going through this, if you have anything you want to ask about, feel free to bring it up. So let's start. I'm kind of a history buff, so I love to start from the very beginning. And to be honest with you, we had autonomous driving long before we had automobiles, because horses were the most beneficial self-driving vehicles on the earth. A lazy cowboy could simply fall asleep, and he knew his horse would eventually take him back to the barn. So we went from being a lazy participant in the transportation world to them moving to horseless carriages. And it's a subtle notification, but you can only imagine how significant it was psychologically for humans to move away from animal technology to horseless carriages, and the fact that they now had to be fully alert when driving themselves in a vehicle, whereas with the horse they could be a little bit lazy. So there's history, if you want to read about it, the catastrophic events that took place in cities as horseless carriages became a reality. It's very interesting what had to happen in order to change the social economic value. So much so that there's a gentleman back in 1925, Francis Houdini, not Houdini, but Houdini, who he went back to a self-driving car. He's like, I want to do this. So he had one vehicle that he did an intercontinental drive across the United States. The first vehicle had the radio operating equipment, and the second vehicle was being controlled by the first vehicle. And so if you look at the history of this, it's kind of interesting that we've been fascinated about self-driving vehicles from the very beginning. So what's the impact of this to society? Well, there's a lot of debate about this, but there's a lot of thinking that suggests that self-driving cars will change the basic construct of our society moving forward. And there's some examples of previous technologies that have done the same thing: the steam engine, the horseless carriage, and the car. Just think about the changes in the infrastructure that had to take place by laying railroad tracks and putting in road systems across the whole country, the amount of jobs that were created, safety issues that were created, massive amounts we had to just reorganize the way we thought about infrastructure and society. Same thing when electricity and plumbing came into play. Same thing when telephones and cell phones came into play. It just shook the foundation of how our society operates. The same with the World Wide Web. So I'm categorizing autonomous driving in this next category because as we go through these slides, you'll see just how impactful this new technology will be, not only for cars, but for society as a whole. So there's a lot of research being done. I pulled this slide from McKinsey & Company because I like the way it structures it into 3 eras. Era 1 is the current era we're in, that's up until about 2020. Then era 2 is from 2020 to 2040. And then era 3 is 2040 and beyond. This is the growth projections of how self-driving vehicles will be consumed within our society. And you can read the bullet points on the left that are in green, but in the first stage, it's all about the car manufacturers getting used to how to collect the data, how to use the data in useful manners, how to create mobility models that the fleet trucks and commercial trucks can take advantage of. And that's the current stage we're in right now. And we've had some of those technologies move into our consumer vehicles with roadside assistance, backing, cameras that help us identify cars in front of us and cars behind us. And that's kind of moving into era 2, where we now take the use cases that are being developed around self-driving cars, and we put them into use in a commercial sense. So you'll start to see self-driving trucks in supply fleets. When you start ordering, eventually when you start ordering Amazon's items online, a driver may not show up anymore. You may actually have a self-driven vehicle in certain city centers that would actually deliver the package to your house. There's examples of this that you'll start to see as we progress on this growth path. Finally, era 3 is where we really start to take advantage of the technologies in the vehicle, and it allows us to really bring down safety issues and take advantage of operational and cost benefits, not only in the commercial space for fleet type vehicles, but also at the consumer level. So what's driving this this revolution toward autonomous vehicles? It's kind of broken into 3 categories. Down at the bottom, you'll see safety and mobility, efficiencies and convenience, economic and societal. And this is an interesting slide because it's statistics that are published by the National Highway Traffic and Safety Administration that has some interesting statistics in these 3 categories. If you've done any reading in this space, you'll probably have already read that over 94% of accidents are in fact caused by human error. So the sooner we can take the human out of the driving, the faster we can recognize safer highways. Up at the top, we have over 49 million people over the age of 65 that have driver's licenses, and that number is only going to accelerate and get larger. And down at the bottom, we have 53 million people with disabilities. So the elderly and the disabled are at a huge disadvantage in our society if they can't have mobility. And so the promise of self-driving vehicles and fleet-operated solutions is a promise that these people are really excited about. And we're starting to experience it now with Uber and Lyft. Those are obviously cars that are driven by humans, but eventually those might be cars driven by themselves. So on the efficiency and the convenience side, another interesting statistic that you may have heard about is, on average, the average American only uses their vehicle 4% of the time. So you bought 100% of your car, and 96% of the time it's sitting in your driveway, in your garage, or in a parking lot at work. And so the promise of fleet services gives a certain segment of society the option of no longer owning a vehicle and just simply renting a vehicle based on usage. And this will bring a shocking cost savings not only to the individual, but it will change the construct of how automobile manufacturers sell and service their vehicles. And that's being evaluated in great length currently. Another statistic is they say that on average, 50 minutes could be saved per person per day with the use of some type of autonomous vehicles. And there's over almost 7 billion hours annually that we spend in our cars as Americans. So what does that mean? So economic and society, if the more self-driving cars we have and we can reduce the population of privately owned vehicles, we have the ability to limit the number of parking spaces that we have. We can convert parking lots to possible parks, or make a major shift in the way we control vehicle parking and vehicle management on roadway systems. There's an estimated $576 billion of economic loss associated with loss of life, injuries related to automobile accidents. There's also a huge economic opportunity to take the free time that people get from no longer having to drive their own vehicles. There's a $242 billion estimate of what the economic impact would be if people could stop driving their vehicles. And that's basically people who could then work in another space or provide additional benefit to their companies and offer economic value that would normally be consumed in just driving a vehicle. So those are some of the statistics. So now that we've talked about what's driving people's interest in wanting to do autonomous driving, let's take a look at the technology a little bit and the car itself. And there's basically 6 levels of autonomous driving, starting with level 0 at the top left, where there's absolutely no features at all the way down to level 5 on the bottom right. And that's a car that can completely drive itself with no human intervention. This car would drive itself, not even being remotely controlled by somebody sitting in a control center. This is a car that's, honest to God, driving itself on its own commands based on the ecosystem of the autonomous network that it provides. So where are we today? So a lot of the cars we have today are starting to get to level 2. Level 2 is where they have a few automated functions. So some examples of those are like lane change, like there are connected car solutions. There's a car next to me on my lane, a backup camera, the ability to identify when you're in cruise control your speed so you maintain the same distance from the cars in front of you, automatic braking. So at least 2 automated features in a vehicle makes that car a level 2 autonomous vehicle. Level 3 is when you can actually take your hands off the car. And there are a few vehicles, Tesla being one of them, where you can actually let the car drive itself. But if any of you have done this, you know you have to keep your hands right there. So they don't expect you to be able to turn around like this picture would depict, where you can talk to your friend. That you still have to be hands-on and ready. But the burden of driving is actually done by the vehicle, and you're still in control. So, and then level 4, you can actually kind of do your own thing, and then the car would alert you when it's time. This would be an example, is like if there was a certain region of the country that wasn't yet certified for self-driving vehicles, you might be coming up on that area of the road, and it'll say 5 miles, you'll need to take control of your vehicle. This area of the road is not certified for self-driving vehicles. You'll need to manually drive it in 5 miles. Please prepare to take over. And you'll get those type of warning signs to help you move into the driving position. So that's how the industry's rating everything. Now let's look at the vehicle itself. This is where all the research is currently being done. And it's really an exciting space to be in right now, because the automobile manufacturers, the fleet companies, the rental agencies are all trying to figure out which technologies for detection are best used in what range. For example, I list 4 technologies on the left: cameras, LiDAR, radar, ultrasound. There's other technologies as well, and they're trying to figure out which can play a role in what areas. For example, cameras get dirty. So if it's raining or snowing, the cameras aren't going to be able to allow you to get to level 5 autonomous driving. At level 5, you have to be able to let the car completely drive itself. So you can't rely on cameras unless the cameras can clean their own lenses. Radar, on the other hand, works very well in inclement weather, but it's not as detailed as you would get with LiDAR, which is laser detection that's very precise in measurements. So there's a big game going on right now on cost versus performance, collecting data, and figuring out how these technologies will work together to advance the whole autonomous driving industry. What's the impact on data? It's massive. Down at the bottom left, just the video data coming in on a vehicle is somewhere between 3 to 6 terabytes of video data per hour per vehicle. Now, a lot of that data could be dumped at the vehicle itself, but there's a lot of it that has to be uploaded and stored and maintained and monitored. You have real-time analytics at the car in order for the car to make immediate decisions on the spot. And then that data is uploaded into a batch file system so that even detailed analytics can be done on to improve the algorithms, to improve the experience, and provide back suggestions on how to improve the overall self-driving experience. But just, I'll show you some statistics on automobiles, but just imagine that we manufacture worldwide over 94 million cars every year. And if every one of those were self-driving vehicles with 3 to 6 terabytes of data per hour per car, you can just do the math and imagine how huge a problem this will be from a data perspective. Now, one of the big things that's happening in the world is the microprocessors are getting faster. So today, these processors are somewhere around 2.5 trillion operations per second, which is great, but as the data grows, the processors have to keep pace. And they're expecting by 2020, some of the companies will have processors that are in around 24 trillion operations per second, which will help accommodate for some of the data migration that takes place. So this slide is purposely complex because I want to show just how complex the data collection is going to be in the vehicle. In the center area where this shows the vehicles, there's examples of all types of devices from your toll tag to your own cell phone to the steering wheel, engine statistic information. All these sensors, and there can be hundreds of them in a car, are all reporting back information about the vehicle. And that data is either being utilized inside of the vehicle or it's going up into somebody else's data silo. So the data receivers in blue at the top are who are we sharing our data with? Well, some of it's going to the cellular network, satellites, city services like emergency services, toll booth information. The automobile manufacturers are collecting that information. They're passing the information on to the service providers that maintain the vehicles. Your car talking to other cars. And this is a massively complex infrastructure that is very complex to manage. This slide comes from the Forum of Privacy, the Future of Privacy Forum group, and they're worried about the privacy of information. A lot of you know recently in the European Union, they've enacted GDPR to help protect personal information. Here in the United States, we have our policies. Other countries are doing the same thing. So they have 4 categories of data that we look at. At the bottom left in the gray box, you'll see where it says vehicle and safety data, driver data, location information, and personal account information. So in addition to managing the data and using it to help drive the car, there's a whole issue about compliance and giving the drivers the ability to opt in or opt out on what information they're willing to share as part of this whole ecosystem. So let me now take it out of the vehicle. So everything I've been talking about has been about the vehicle itself. So now I'm gonna ask you to think a little bit more broadly on what the smart city and the smart country implications are as we make the cars smarter. How does that impact our infrastructure? This is a slide from a couple of engineering organizations out of Germany who are exploring this scenario. This first circle, the green data centers up at the top right represent city services. So a city that's like San Francisco or Detroit or Singapore or London, they're capturing data about their smart cities. So it could be the police department, the fire department, the traffic light systems, medical services. All that's, as we continue to drive toward a smart city ecosystem, that data is being shared with the vehicle. On the infrastructure side, all of our telcos and wireless providers are having to step it up as well. Most of you know that that 5G is coming very soon, and that's going to be a huge advancement in the ability to upload data in real time to help accommodate for the future needs of self-driving vehicles that need to talk to the infrastructure and need to talk to city services. So the carriers have to be in tune with this on how to help the ecosystem grow. And then finally, it's the cars itself, which I've already spoken about. So it becomes very complex now as we start to see how the data will be communicated across multiple systems, multiple agencies, multiple organizations. So this gives me a chance to let's talk about the impact of the data and on the analytics side. I mentioned earlier, this is a from 2016. This is the manufacturing of automobiles by each auto manufacturer. So I'm listing the top 1,400 here, but there's much more than that. But just the top 14 auto manufacturers manufactured almost 75 million cars in 2016. And what we're going to see as this whole economy shifts is who will be the future purchaser of the car. Will it be the individual consumer, or will it be fleet operations and commercial and car rental agencies? All that's being explored right now. But one thing's for sure, when it comes to self-driving autonomous vehicles, as I mentioned earlier in the slide deck, the commercial fleets will be first to adopt. So these manufacturers are creating automobiles that are uniquely suited to meet commercial fleet requirements. So you might be on an interstate somewhere near where you live in the next few years, and you'll see maybe the right lane. You might see some semi 18-wheeler trucks that will become self-driven. It'll be freaky. Obviously, I can only imagine what it's going to feel like to drive past a truck while you're going to some destination with your family, only to find out that it's driving itself. And it'll be an interesting adoption as our society learns to deal with this concept. The next area will be fleet operations. So this is rideshare companies, perhaps Ubers or Lyfts. Google's into this business, Hertz, Avis. All these companies are trying to figure out what role they'll play in the rideshare business space. And then consumers. There's a lot of us, to include myself, that we think we'll never want to give up driving our own car, but there's a lot of people out there that would love to have somebody else drive for them. So the adoption of these vehicles over time will happen in this type of scenario. The impact, if they're manufacturing millions of cars a year, and those cars stay on the highway from 5 to 15 years, you can imagine the amount of data that will be produced. So how do we take care of that? Well, first of all, compliance plays a major role. This is an area that Quanta is doing a great deal of research in, but on the left, you'll see the global implications of different countries who are making up their own compliance rules. As you move to the right, each country will have their federal, their state, and their local rules and regulations. And all of this is a crapshoot right now. The agencies are trying to figure out what role they should play. But there are three categories of concern that are driving compliance. PII, which is personal identifiable information. This is your own private information. What are you willing to share and not share? That's a very strict area of compliance. Safety. Personal safety as well property safety. How are we managing data information to ensure the maximum safety of these cars? And then liability. It's inevitable that even though the promise of fewer accidents could be a reality, the fact is we will have issues, and the insurance companies and the legislation and the different legal authorities are going to want to know how to be able to do forensic evidence to show at what point did the data mess up and what caused the event to happen. Was it human? Was it technology? Was it the automobile manufacturer? What was the failure? We have to be able to track all of that. And currently, compliance regulations are completely submersed into this concept. Let me give you an example. Just within the United States alone, the autonomous driving policies are going to be driven by multiple agencies: the Department of Transportation, the FCC. Each one of those organizations have subcommittees. I've listed a few of them on the right-hand side: the Office of Policy, the Federal Highway Administration, Office of Engineering and Technology, the Enforcement Bureau, Public Safety and Homeland Security. These are all departments in the United States government that have a voice in how compliance will eventually look. So most countries, the United States being one of them, is making significant investments already into how to take a look at this. Everybody's got a different approach. I'll show you what the United States is doing. The National Highway Transportation and Safety Administration has categorized compliance into 12 buckets. And you can read them for yourself. And on their website, you can get in, you can look it up yourself or get a hold of Quanta, but there's a specific guidelines that are provided in each one of these 12 categories. And it's a work in progress right now. This requirement of the NHTSA currently doesn't mandate compliance rules, but they're asking all automobile manufacturers to voluntarily commit to these 12 categories. So there are companies that are already making efforts to report back to the U.S. Department of Transportation these 12 categories. Everything from system safety on the top left to human-machine interface, cybersecurity, crashworthiness, consumer data recording, and in managing federal laws. The U.S. Department of Transportation has also asked all the states and local agencies to not mandate or legislate anything around compliance for fear that it might impact the way the companies drive towards successful innovation. So if you want more data about that, just reach out. But it's an interesting because over in Germany, they have a slightly different take. Germany is more worried about the moral aspects of a robot making decisions on humans. So like if there's a crash incident about to occur and the computer system is trying to decide which way for the vehicle to drive in order to minimize the wreck, what's the fair choice to decide which other vehicle gets consumed in the wreck, or what happens to the people in that car? So there's policies being put in place about how to keep a level playing field when it comes to choosing best case scenarios during crash scenarios. Interesting conversation, but there's a lot of topics around that, so feel free to reach out. So what does this look like? From a data perspective, the orange circle represents what we've talked about today. Autonomous driving, self-driving vehicles. You can tell by the slides I presented, the complications of getting our hands around self-driving vehicles is a massive undertaking onto its own. This gets much more complicated when we start getting to smart city technologies and the advent of big data, and how do you bring all of these teams together, whether it's retail companies, manufacturing facilities, city services, healthcare, telemedicine, traffic control. All of these systems have to talk to each other in order for us to be highly successful. And it just creates additional data silos, additional complications in how to manage the data, multiple complications on compliance management. Where is the data coming from? Where is it going? Who do you share it with? All those things are huge questions that are being answered right now. So let's take a look at that. Let me simplify it down a little bit. Each one of those agencies I had on that slide ultimately represent a data silo onto itself. Arguably, even inside each of those groups, there's multiple data sources that are being accessed at that level. And then all those data sources need to be compiled into an ecosystem for smart city success. So how do we do that? So I'm gonna try to peel it back a little bit from the complicated efforts that I was sharing with you during the slide deck. You have the ability to pull in technologies. Companies like Knowi, Quanta, and Cloudera are putting technologies in place to make this very complex data problem become something we can actually start to take control of. And for today's purposes, let's talk about this. Knowi has the ability to access very distributed data sources from multiple locations without actually moving the data. So the data can stay stored in the source that it currently resides in, and the queries are built so that it can access the data in those multiple locations and create analytics findings and tease out interesting insights about that data without the data moving. Cloudera is a massive scale big data repository that does compute and storage in the cloud, on bare metal in the data center, or a hybrid model of each. So it gives you the ability to do very high level security access, compliance, governance, on all of your data so that massive amounts of scalable data can be brought in of all data sources, whether it's structured data, unstructured data, social media versus tabulated data, can all be brought into a single huge repository. That's one of the data sources that Knowi could access as part of their analytics efforts. And then Quanta has the ability to come in and actually help make this a reality by doing the consulting work, driving into the detail of each of the use cases. If you're trying to fix your compliance concerns, if you're trying to do IoT predictive analytics, they can come in and work with you specifically around the use cases that you're trying to drive out of your data. So to take this complex smart city solution, we scale it down to something a little more simpler. Of course, the slide makes it look a lot easier than it really is in the real world. But on the right-hand side, you have multiple sources of data that currently exist. Quanta can be the glue in the middle that would help integrate these data sources and allow for compliance and use case innovation. And then Knowi on the left side of the screen can tap into these multiple data sources to bring out the analytics associated with your particular use case and to help drive helpful insights into your business processes and your data. So with that said, what I'd like to do is turn it over to Manny. And Manny, if you'd like, you can go ahead and take control here and dive into the demo.
Sounds good. Thanks so much for that, Ash. Let's get this going. And put this in presentation mode. So for this next piece of the demos, to talk about a use case with Tampa, Florida. And with this data set, it's from the Tampa CV pilot, which has data that's been generated from various interactions between vehicles to vehicles and as well vehicles to infrastructure, which really connects the rest of the conversation with what Ash was just talking about with connected vehicles and how that data is being moved and how you can explore that data and provide an actionable insights from that. And so from this, what we're going to look through and run through with this demo is run through a few visualizations of what we've explored with this data sets and how we connected to a REST API using Knowi and working and how Knowi natively works with various JSON files and natively integrates to various other data sources and take a bit deep dive into some of the features of Knowi and how in a very seamless process you could connect to your data sets and be up and running with various visualizations and actionable insights from that. So let's switch the screens and jump right into that. So what we've done here, once again, is using the Tampa data sets, we've created various visualizations. On the left side here, we have a geocoordinates data which plots the traffic patterns, as you can see on the left side with some of the highlighted patterns to that, of vehicles in motion and the amount of data that's sent to various substations around the city in small infrastructures. And then also we've created a few, on the top right side of the screen, there are some, we've calculated some min, max, and medians to create a few box plots showing the speed ranges of various cars and showing the min, maxes, and various quartiles of that. On the right side as well, we have just a very simple pie chart to that, and on the bottom here, bubble charts. And interestingly, in the bottom here, this is something that we can step through as well, which is an anomaly detection. It's particularly useful when you have a time series data sets and you can find out and quickly see where there are some anomalies or outliers within your data sets. And in this sense, we can see here for this particular vehicle and time series, there's some spikes in speed, and we can step through that a little bit later on as well. And the other thing to mention as well in the speed distribution of this vehicles, and using the box plots, for instance, this is something where we've with Knowi, you can have drill downs to your data set, in which by that, it's having an action from one widget or one data points drill down to another data set that you've set up on top of that. So taking this as an example, once again, it's this we've separated out the vehicles and created box plots for that. And so by clicking into one of them, we can drive deeper into seeing what's going on behind this particular vehicle, and then as well from there going a little bit further. And it's a little hard to see here, but these are the two data points from this particular Thea 12 vehicle device. The other thing as well to that is, once again, it's by using just one data set, one data source, we've been able to create multiple visualizations from this. And let's step through what that looks like and give a quick preview of that. So this, with this pop-up gives you it really allows you a very simplified flow to see from an end-to-end the life cycle of your data and what's powering your charts and widgets. And so as you can see on the left side with this orange panel, it's just one master query that's been a virtual data set, which is a Knowi lingo, and some of you might be familiar with this terminology, but essentially it creates a virtual data set that you could now drive or use to create as many widgets as you can from that. Let's jump into the query and see what this looks like here. And now from this particular data source, this is pulling in from an API from the Tampa CV API. And once again, with Knowi, it's a very straight and very easy integration using Knowi to connect to various data sources. And we can step through a little bit of the various data sources that we do support and how you could very quickly access your data set. So it's, from here, we set up our endpoint. That's where the data source is coming in from. Let's preview this and see what the data looks like. And on top of that, whatever data is returned, you can write queries on top of that using the Knowi Cloud9QL query, which is a very similar, it's a SQL-like syntax, which gives you an additional powerhouse to really dive deep into your data set, into your query, and manipulate and aggregate data as you see fit. So with that, let's get a preview of what the raw data looks like, and with some manipulations on top of that. Let's take a look here. Let's see, let's try this. Okay.
Worked yesterday.
Well, that's okay.
Get rid of the where statement, Manny.
I'm sorry?
Get rid of the where statement. Maybe it's the hours are screwing it up.
Let's
there you go.
Let's try this. Bring this down. There we go. Yeah. So once again, it's what we've done so far is we've called an API, called the Tampa API, and this would be the same motion as well. If you recall, in any other API source, you put in your parameters, and very quickly on the fly we could preview the data, and then from here apply various calculations to that. So let's as well. The other things that you can do with your data set is write functions on top of that. And so with this, we've done a on-the-fly calculation of transforming the data set, one of the fields returned from the original data source, and transpose that data into a function that write a function to transpose the data into a usable format that makes sense to the end user. And so with this, we've rewritten the formula from I believe kilomiles per second to miles per hour, and that's once again something that with Knowi you can customize and really play with your data and get down to that. And by being able to connect to multiple sources, from this query we are only connected to an API REST API data source, But imagine if you do have various data sets across multiple different locations and different data source types as well, from Mongo, NoSQL sources, Postgres, and relational sources as well. And just to give a quick highlight of some of the various data sources that are supported and natively integrated. Everything from your more popular Mongo, Elasticsearch, and NoSQL data sources to MySQL, Postgres, and as well a very popular one, REST API, which is what we showed just now. To jump back into the data and to the dashboard, something else that's very simple to do and it gives you action into stepping into your data very quickly is using the natural language querying. And so from here, this is the raw data sets that we pulled in from the Tampa CV. And let's say we wanted to find out some quick information and as well just query the language. This is something that the business user can use without having to reach out to an engineering team or to a data analyst. And they can interact with the data just using natural language. We could just search things, and as you start typing, some recommendations will be presented to you. You can either pre-select those or continue with your query in mind. So let's go. We wanted to find out the average speed of miles per hour by hour. Let's go with this bit and break that off as well by the vehicle types. And so it's as much as writing the query out, the calculation has been computed on the fly for you, and you can take this data set and turn that into a visualization. Let's apply a line chart to this, make some minor adjustments to how our data is rendered. Let's go with linear axis. And now from here, we could turn this into a new widget and put that onto our dashboard. Let's call this average speed by hour. So that already exists. Let's by RSU ID. And so just like that, we've added this to the dashboard. And let's refresh the page quickly. And we could see on the bottom here in what we've recently added. And so we've used this data set here and in as much as 30 seconds, created a new query and a new visualization and added that into our dashboard, all still while maintaining the original data set that's still here and the true data source from the REST API untouched. So we've, once again, just to quickly recap, we've used one data source and one master data set from the REST API to create 9 widgets out of that. And that's something that really, once again, it's just it gives you the flexibility with Knowi. It gives you the flexibility to interact with your data set and across various different data sources, blending across different data sources and data types into creating just visualizations and dashboards that can be used and easy to use and easy to manipulate and really provide some actionable insights on top of that. And so with that, I'm going to transition that back to Kim.
Great. Thanks, Manny. So now is time for Q&A. We have a few questions that have come in already, but if you have any additional questions, please hit the Q&A button on your panel and type in your questions. So I'm going to start off with one for Ash, I think. So when you went through the connected vehicle scenario, so what do you think are some of the impacts to, so the commercial vehicle market?
Yes, so probably the commercial impact is what the question is about. So
right.
Yeah, so there's going to be 2 interesting events that take place. what happens in the car itself and what happens to the larger retail market space. So in the vehicle space, you're going to see a complete shift in the way cars are purchased, sold, marketed. And initially, fleet operators are going to be the biggest purchasers of self-driving vehicles. The bet is still out on how it's going to impact individuals, because if you're getting your vehicle through fleet operations and you don't own your own car, that's going to change the way, it's going to change the way you buy your vehicle. First of all, you don't buy one. Second of all, you're just leasing it on a monthly basis from one or more different providers. Number two, insurance companies, since 94% of accidents are human related, if that number starts to drop, the insurance companies are going to have to completely change the model that they use to charge for automobile insurance. Thirdly, service departments. If you are getting your vehicle through fleet operations, you no longer have to go and take your car into the mechanic and drop it off to be repaired. It's going to be fixed for you. So those are three obvious areas where the other area obviously is public transportation. If suddenly you have the ability to get in a bunch of self-driving vehicles, that should take a lot of the burden off of the subway systems and other public transportation mechanisms. And it also changed the way we park and the way road networks will be built and serviced. Then on the retail side, there's going to be an amazing transformation, because suddenly that time that you've spent in the car is now free. So the in-cab experience is going to be the most interesting change in the car, because you no longer have to worry about a steering wheel. Seats can be positioned in different directions. You can focus on watching television, surfing the net. So shopping is a huge opportunity for retailers to now market to people that are driving in vehicles. Other retail examples are companies like Pizza Hut are going to have self-driven pizza ovens that will basically be on Super Bowl weekend, rather than delivering pizzas from the Pizza Hut, they'll know based on last year's consumption where to park their self-driven ovens and have vehicles be able to deliver pizzas in an automated fashion. So just think of those examples.
Yeah, so all I'm thinking of is how fat and overshopped I'm going to get.
Yes, that's right. Just make sure you make a lot more money. Okay.
Yeah, exactly. Because I'm basically going to need to self-drive myself to the gym every couple of hours by the sounds of it. So a different question. This one probably for Manny, more on the technical side. So there was a lot of talk about the volume of data and everything. So from a Knowi perspective, how are we prepared to sort of handle the volume of data that's going to come up from all of these different sensors and devices and the street level units?
Yeah, great question. So it's, from the Knowi perspective, so the way we approach data and large amounts of data is we provide this concept of a virtual elastic store. And so when you query your data set, you have an option to, without doing a direct query, doing a scheduled query. And so what that does is it creates a virtual data set on Knowi, and really, it's very much optimized for speed and prevents load from your true data source. So we don't ping your data source, your true data source, unless the scheduled, it's time for the scheduled query to refresh the new data set, or you manually trigger that data set. And so what that gives you is high flexibility and speed to really for Knowi to handle high amounts of data and high volumes of data, and as well as doing a lot of the processing in memory and cache to preserve the load on your data source.
Okay, cool. There's sort of a second more technical one that I'll just pitch over to you, since you're already talking, Manny.
Oh, fun.
And that's around the arrays. So I know in that JSON file that you were exploring, there was at least one array for the coordinate data.
Correct.
So can you kind of explain a little bit more about like how we support arrays within data sets?
Yeah, absolutely. So to that note, you know, particularly if you imagine using a lot of NoSQL or unstructured data sources, the structure to that can have a very deep nested structure and schema to that. So with Knowi, what we do is once you connect your data source to through Knowi, we scan through that schema or through the collection or tables and identify where there are nested objects within that and automatically unwind or unnest the various objects that are nested. And there are no limits to how far we can unwind that. We've had use cases of users with literally close to 100 child nested objects within a parent object. And so once again, that, you know, it gives you the flexibility of pulling apart your data and being able to dive deeper into that. And alongside that, there's it's just worth mentioning, and maybe I'm getting too excited here. There is as part of the Cloud9 QL, there is an expand function, which if you have a nested object, wrapping this expand function around that field automatically unwinds that for you, still giving you another multiple ways of accessing your data, regardless of if it's a nested object or just a flat tabular object. And the limitations to how far that can go is dependent on your schema's setup.
Okay, cool. Thanks for that. So we have time for one more, and it looks like Ash is going to be the winner. So you touched on it a little bit around the compliance stuff, but obviously it's a hot topic, data compliance these days. So can you talk a little bit about how some of the companies are addressing data compliance?
You bet. It's a very broad methodology right now. Most of the people in Europe are focused on GDPR, so their goal really isn't focused on autonomous driving so much as it is making sure that they meet the GDPR spec that's over there. And what's happening now is companies are doing one of two things. The automobile manufacturers are in the early stages of developing this whole use case and testing and figuring out what the data needs to be. So a lot of them are just doing self-compliance right now because they're not really in a production role. They're not selling it to consumers, so the liability is not quite there yet. So it's kind of being explored but not mandated. So they're taking it on a more casual basis, and each company has a different priority with how fast they're utilizing it. That's for the and then some companies are reaching out to third parties to help build a compliance solution so that they can work with companies like Quanta to say, okay, what does the requirements look like? How do we set up our infrastructure and our data flows so that we can capture the correct information? So there's really not a prescriptive method on how it's being mandated. The local laws are kind of driving the economic investment. So GDPR in the UK or in the European Union, here in the United States, it's more around private information rules that we have in place. And that's about the extent of it. But I think that's going to ramp up over the next few years as it starts to become more of a commercial solution. Okay.
Yeah, that makes sense. Cool. Well, that's the top of the hour. So I'm going to thank our speakers today, Manny and Ash, for all of your great insights and the demo, Manny. And I certainly thank all of you for your time today. And that's going to conclude our presentation. Thanks very much.